Welcome to today's lesson. Today we are going to look at Form 3 Chemistry under the topic Organic Chemistry 1, and we are going to begin by introducing ourselves to the topic Organic Chemistry. And we can say organic chemistry is a branch of chemistry. That studies structure, properties, and reactions of organic compounds which contain carbon covalent bonds It's a branch of chemistry that deals with the structure. We have properties and the reactions of organic compounds which contain carbon covalent bonds. Organic chemistry 1 is going to focus on the simplest organic compounds, and the simplest organic compounds are known as hydrocarbons. The simplest organic compounds are called hydrocarbons. The simplest organic compounds are called hydrocarbons. So we need to find out what hydrocarbons are. So when we talk about hydrocarbons, we say from the word itself, hydro and carbon, it is a compound or a hydrocarbon. A hydrocarbon is a compound comprised of carbon and hydrogen atoms only. Any compound that is made up of carbon and hydrogen only, we call it a hydrocarbon, as the name suggests. Based on the type of covalent bond between carbon atom, hydrocarbons are classified or grouped into 3 classes. So we can talk about groups, or what we can call classes of hydrocarbons. Classes or groups of hydrocarbons. We have 3 classes of hydrocarbons, namely we have the first class known as alkanes, we have alkenes, then 3 we have alkynes. Those are the 3 classes or groups of hydrocarbons, and we are going to begin with the first class of hydrocarbons, which we call alkanes. So what are alkanes? We can say alkanes are hydrocarbons whose carbon atoms are linked by a single bond. Alkanes are hydrocarbons whose carbon atoms are linked by single covalent bonds, are hydrocarbons whose carbon atoms are linked or joined by single covalent bonds. And because of the single covalent bonds, alkanes are said to be saturated hydrocarbons. We say alkanes are saturated hydrocarbons. In other words, hydrocarbons whose carbon atoms are linked by single covalent bonds are said to be saturated. Another thing we need to understand about alkanes is that the single bond in alkanes is their functional group. The single bond, that is the single bond in alkanes, the single bond in alkanes is their functional group. The single bond in alkanes is their functional group. So what is a functional group? A functional group is that part of the compound which determines their chemical properties. Another thing that we need to understand about alkanes is that all alkanes conform to a general formula. They conform to a general formula of CnH2n plus 2, that is CnH2n plus 2, where n is equal to the number of carbon atoms. All alkanes conform to a general formula of CnH2n plus 2, where n stands for the number of carbon atoms. Another thing that we need to understand is that the smallest alkane is methane. The smallest alkane is methane with a molecular formula of CH4, and in this case n for the smallest member in alkane is 1, where the value of n, where we can say where n is equal to 1. It means the first member in alkanes has only one carbon atom. For us to understand how to derive other members of the alkane family, we are going to draw a table. We are going to draw a table to represent the first 10 members in alkanes. So we are going to begin with the number of carbon atoms, which we can call n. Then we move to the name of the alkane. Next we talk about the molecular formula. Then we talk about the structural formula. In this case, We are going to begin with the first alkane with one carbon atom, and we have already said the smallest member in alkanes is methane, that is its name, and the molecular formula of methane is CH4, and you can see it has only one carbon atom and therefore N is 1. And to draw the structural formula will show you how the different atoms of an element are arranged in a compound. The first thing we do is to draw carbon, then it's bonded to 4 other hydrogen atoms. So we have hydrogen here, hydrogen here, hydrogen here, and another one here. This is what we call an open structural formula. We can close that. Then we go to the second member. We go to the second member, and the second member has 2 carbon atoms. The second member has 2 carbon atoms, and the second member is known as ethane. So we are going to use the prefixes meth to mean 1. We have eth means 2, so this is an alkane. We call it ethane. And the difference between the first member and the second, they differ by CH2. And in other words, the number of carbon atoms increase by 1. So we have 1 carbon atom, we are going to have 2. Then the number of hydrogens will increase by 2, such that we have C2H6. And in this case now, we are going to draw the structural formula by first drawing the carbon atoms, then we feed the number of hydrogen atoms. So we have 1, 2, 3, then this is the 4th one, then this one has 1, 2, 3, and you can clearly see that we have 2 carbon atoms and 6 hydrogen atoms. We move to the third alkane, and the third alkane has 3 carbon atoms, and the third one we call it that is propane. Prop means 3, so the third member in alkanes is propane. So the number of carbon atoms are going to increase by 1. So from 2 we are going to 3. Then the number of hydrogen atoms increase by 2. So from 6 we are going to go to 8. Then now when representing it in terms of the structure, we are going to first draw the carbon atoms since we have 3. Then we have 8 hydrogens. The middle one is going to have 2 hydrogens. Then this is 1, 2, 3. And by so doing, you'd have drawn the structural formula of propane. Then we move down. And draw the structural formula of the 4th member. The 4th member has 4 carbon atoms, and we call it butane. But means 4, and therefore we are going to have 4 carbon atoms. Then the number of hydrogen atoms are going to increase by 2. So from 8 we are going to have 10 hydrogen atoms. In this case, we are going to draw the structure by first drawing the 4 carbon atoms. Then we feed the number of hydrogen atoms, that is 1, 2, 3. This is 4. The middle carbon atoms will always have 2, that is for alkanes, and the outer ones will have 3 hydrogen atoms. And in this case, now we have drawn the structural formula of butane. Let us go to the 5th member. And the 5th member has 5 carbon atoms, and we call it pentane. That is alkane. Pent means 5, so we are going to have C5. Then H is going to increase from 10 to 12. Or you can simply say if N is 5, then you go and substitute it in the general formula for you to get the C5H12. And the structural formula is going to be, we draw the 5 carbon atoms first. Then we feed in the number of hydrogen atoms. The outer carbons will always contain 3 hydrogen atoms for alkanes. Then the middle ones will have 2. You see they are linked. The carbon atoms are linked by single covalent bonds. That is the structural formula of pentane. Then the next one is going to have 6 carbon atoms, and in this case the one that has 6 carbon atoms, we call it hexane. Hex means 6, so we are going to have C6. The number of hydrogens are going to be multiplied by, we take the number of carbon atoms, we multiply by 2, we add 2, then we are going to have 14. In this case, we are going to first draw the number of carbon atoms. We have 6. Then we feed in the number of hydrogen atoms, that are 14. The outer carbons are going to have 3. Then the middle ones are going to have 2 hydrogens each. And in this case now, we have drawn the structural formula of hexane. Next, we are going to move to the one that has 7 carbon atoms. And the one that has 7 carbon atoms, we call it heptane. Hept means, the suffixes hept means 7. So we are going to have C7. Then the number of hydrogens are going to increase to 16. So you can see for alkanes, you take the number of carbon atoms, you double them, then you add 2 for you to get the number of hydrogen atoms. In this case, to draw the structural formula, you first begin by the number of carbon atoms. That's supposed to be 7. 1, 2, 3, 4, 5, 6. Then this is the 7th one. The outer carbon atoms have 3. The middle ones will have 2. And that is the structural formula of the 7th member, which we call heptane. I want us to draw the first 10 members of the alkanes. So we move to the one that has 8 carbon atoms, and the one that has 8 carbon atoms, we call it octane. That is, we are going to have C8. Then the number of hydrogen atoms, just multiply the number of carbon atoms by 2, then you add 2. That will give us 18. And then now, the molecular formula is C8H18. Let us draw the structural formula. We have 8 carbon atoms. That is 1, 2, 3, 4, 5, 6, 7. Then 8. This one is going to have 3 hydrogen atoms. The outer ones are going to have 3. Then the middle ones are going to have 2 each. That is for alkanes. This is what we call the open structural formula for alkanes. This is now octane. We are going to move to the next, which is nonane, that is the 9th member with 9 carbon atoms, and the name is nonane with 9 carbon atoms, that is C9. Then H are going to be 20, that is the number of hydrogen atoms. And in this case now, we are going to start by drawing the number of hydrogen atoms, the number of carbon, sorry. So we have 9, that is 1, 2, 3, 4, 5, 6, 7, 8, 9. That is 1, 2, 3, 4, 5, 6, 7, 8, 9. The outer ones, as we have said, will have 3 hydrogen atoms, that is for alkanes, and the middle ones are going to have 2 hydrogen atoms, because each carbon atom must be covalently bonded by 4 other hydrogen atoms. And that is the structural formula of nonane. And the last one is the one that has 10 carbon atoms, and we call it decane. That is the 10th member that has 10 carbon atoms. Then the number of hydrogen atoms are going to be 22. Then now the structural formula is going to have 10 carbon atoms. Those are 3, 4, 5, 6, 7, 8, 9, and lastly 10. Then we feed in the number of hydrogen atoms. The last ones are going to have, the outer ones are going to have 3 each, and then the middle ones are going to have 2. So you can see it is very, very straightforward. So those are what we call the structural formula of these alkanes. So you can see we have the molecular formula and also what we call the structural formula. So what does the molecular formula represent in this case? We can say that the molecular formula, as you can see, the molecular formula shows you the atoms present in the compound and the proportion in which they exist. So we can say the molecular formula, is a formula that shows the elements present. It shows the elements present in a compound and the proportion of their atoms in a compound. In other words, how many, for example, carbon atoms are in decane? We have 10. How many hydrogens are in decane? We have 22. That is what we call the proportion or the ratio. We also have what we call the structural formula. And the structural formula will show you how the different elements of a compound are arranged. So we can also say that the structural formula is a formula that shows how atoms of different elements are arranged in a compound, are arranged in a compound. Another thing we need to realize is that a group or a series of compounds such as those of alkanes form what we call a homologous series. NB, we can say a series of compounds such as those of alkanes, form a homologous, they form what we call a homologous series. They form what we call homologous series. So it is important to know some of the characteristics of our homologous series. Characteristics of a homologous series. Characteristics of a homologous series. Number one is that all members conform to the same general formula. All members conform to the same general formula. In other words, all alkanes conform to the same general formula, all alkenes conform to the same general formula, and also all alkynes conform to the same general formula. So for the alkane homologous series, they all conform to a general formula of CnH2n plus 2. Another characteristic is that all members of a homologous series show similar chemical properties. They show similar chemical properties. That is the second characteristic. The number three, we can say the physical properties of the homologous series change gradually. That is, the physical properties change gradually. That is due to the increase in the number of carbon atoms, and also as we move down, you can see that the size of those compounds increase gradually. That is from the smallest to the largest. The fourth characteristic is that all the members of a given homologous series have the same method of preparation. They all have similar method of preparation. They all have similar method of preparation. Another thing that we are going to talk about in our next discussion is isomerism in alkanes. Thank you for watching and welcome to the channel.